Okay, so we're going to work with one sample proportion confidence intervals. This is page 171 through page 181 of the note spiral. This first page where it talks in general about confidence intervals, I'm not going to read everything. So you need to actually study this page. But remember that the purpose of a constant confidence interval is to estimate a range of plausible values for the parameter of interest. In this case, the parameter of interest happens to be a proportion. All right. So it's the estimate plus the margin of error. So anything after the plus or minus is the margin of error. All confidence intervals are two-tailed, which means alpha is in both. So if I have a 95% confidence interval, alpha equals 0.05 because it's the area in the tails. All right. As we increase the level of confidence, the margin of error, the interval width increases. So this is really important. This section right here, you really need to know. So as confidence level increases, the margin of error or width increases. As we increase the sample size, the margin of error decreases. So the interval width decreases. As we increase the standard deviation, the margin of error increases and the interval width increases. Because we only have sample data, we are never able to say that the exact population proportion or mean is. We claim with a certain level of confidence that the population proportion or mean lies within an interval, and the sample proportion is always the center. All right, the sample proportion, which is p hat, is always the center. Please remember p hat equals x over n, where that is success over trials. Our formula is p hat plus or minus z star, and I want to point this difference out because we had been working with a x bar plus or minus t star s divided by the square root of n. So our best estimate for the population mean was x bar. Our best estimation for the population proportion is p hat. Here we use a z star, and for proportions, just so you know, anytime we're working with proportions, it's z star. Here we're using a t star because we're using the sample standard deviation. Okay. This part right here, anything after the plus or minus, margin of error. This part right here is the standard error. Okay, the margin of error is the maximum distance a sample statistic may lie from the true population mean. So the maximum, and it probably should say plausible distance, the maximum plausible distance, because we don't talk about things that are unplausible, okay? Please remember, we can claim 90% confidence that the true population proportion lies within an interval. And we can claim 90% of the intervals collected by this method will capture the true population proportion, which means if we did this over and over and over and over again to an infinite number, 90% will contain it. This is super important. We are making a claim about the population proportion and not the sample proportion. So we're claiming that it contains the population proportion. We're not claiming that it contains the sample proportion. Why? 100% of samples will have that. 100% of intervals will have the sample proportion, and it'll be in the middle 100% of the time. What we're saying here is we're doing a 95%. We're saying 95% capture the population proportion, but 100% will have the sample proportion, and it will be the middle value because we have p hat plus or minus z star p hat q hat n. All right, these are the things that we cannot claim. We cannot claim that 90% of the values lies within the interval. One, we may have a wrong interval. Two, the shape could be weird. All right. Whereas the average will be in there, the average proportion will be in there, but but we may not have 90 or 95% of the values. We cannot say that there's a 95% chance that some value will lie within the interval. Once again, the interval may be wrong, or we may have a weird shape. And we never talk about probability. 95% of samples result in this interval. Once again, all intervals are going to be different based on the sample, so we can't make that claim. And once again, we never ever talk about probability. All right. And remember that the purpose of the interval is to provide a range of plausible values. All right, to a range of plausible values. If the claim lies within the interval, then there's not enough evidence to reject the null. We can't say things are significant. So we can't say that it's not true. If it lies outside of the interval, then we can say, hey, based on our interval, the claim is false. So if it's in the interval, we can't reject it. It's plausible, may not be true, we don't know, but it's plausible. On the other hand, if it's outside of the interval, we can reject it. So, couple things. This is confidence interval, just a couple things that we see students miss all the time. So we have a couple multiple choice, and this is page 179. Please remember that although the population does not change, every sample is going to be different. Hey, this is really important. The population does not change, but every sample is going to be different with a different mean and a different standard deviation. As a consequence, every confidence interval will have a different point estimator. All right. And whether it's X bar or P hat. So your sample may have a different sample mean or a sample proportion than mine has, just because we took different samples. Also note, we do not have any confidence in the endpoints. We are confident in the method, but we're not confident in the endpoints. They're going to vary. And we only make claims about the population. We never make claims about the sample because we know all the values in the sample. I'm just telling you, I would study this and try my best to understand everything there because there's a lot of information there that's missed frequently. So to determine the average spent on entertainment during a year in college, a simple random sample of 35 students is interviewed, showing a mean of 825 with a standard deviation of 240. Which of the following is the best interpretation of a 90% confidence interval estimate for the average spent on entertainment during a college year? Well, the first question answered. 90% of college students spend between $756 and $894. No, that's not what we said. That we're saying we're 90% confident that the true population mean lies there. We're not saying what anyone spends. We could have a very weird distribution. In which case, what if it were shaped like a parabola? Well, the mean would be here, but actually very few people would be spending that amount of money. Next thing, 90% of college students spend a mean dollar amount on entertainment yearly that's between this. Once again, because of a shape like this, we don't know. All we're saying is the population mean is contained in that interval. We are 90% confident that college students spend between $756 and $894 on entertainment a year. All right. And I would even be happier if it said we are 90% confident that the college students average is between this. Okay. But 90% confident they spend between this. So this is possible. So this is a good answer. We'll see if there's a better one. We are 90% confident that college students spend a mean dollar amount between $756 and $894. And just pause this for just a moment. And okay, so I'm reading this thing and I'm rereading this and I go, spend between $756 and $894 on entertainment on average. And we're missing the on average part. So while I like this, I don't like it as much as the next one. So I'm not sure why it's highlighted here. So we are 90% confident college students spend a mean dollar amount, an average dollar amount between 756 and 894. That is what we're more confident about. So this is not, C is incorrect. D is the what we should be looking at. And we are 90% confident the chosen sample, the mean dollar amount spent on average entertainment by yearly college students is between this. This is talking about the sample. All right. We never talk about the sample. We're talking about the population. All right. So our best answer is D. And the reason D is better than C is because we're talking about the mean dollar amount. The problem with E is talking about the sample. Okay. And we're always going to be talking about the population. So confidence intervals talk about the focus on the population. They focus on the mean or the proportion, and we never talk about probability, and we never talk about the endpoints. We never talk about the number of values. All we do is talk about the population mean or population proportion lying within the interval. So our best answer here is D, and I don't know why C is highlighted. That is incorrect. Number 2, a planning board in Elm County is interested in estimating the proportion of its residents that are in favor of offering incentives to high-tech industries to build plants in that county. A random sample of Elm County residents was selected. All of the selected residents were asked, are you in favor of offering incentives to high-tech industries to build plants in your county? A 95% confidence interval for the proportion of residents in favor was calculated to be 0.54 plus or minus 0.05. So basically, this means our range is 0.49 to 0.59. So it's possible that less than half are in favor because it contains 50%. So letter A, at the 95% confidence level, the estimate of 0.54 is within 0.05 of the true proportion. And this is really important. Earlier that we said the margin of error tells you how far we think our sample proportion is from reality. So we were saying that this is 0.54, our margin of error is 0.05. So we believe that this is no more than 0.05 away from the true population. So because we believe it contains it, we're 95% confident that it's no more than 0.05. So this is actually pretty good. It looks pretty good. At the 95% confidence level, the majority of area residents are in favor. Well, we don't know that because we include below that. Yes, I know it's skewed to the right or it's above it for the most part, but 49% is below 50%, so that's false because 49% is a plausible value and may be right. In repeated sampling, 95% of our samples will fall within this interval. No, that's not what we say. We do not say that it falls in the interval. We say 95% of our samples will capture the true population proportion. Say not 95% of the sample proportions fall in that. Because once again, what if we end up with a shape like this? In repeated, so C is wrong. In repeated sampling, the true proportion of county residents in favor of offering incentives to high-tech industries to build plants will fall within the interval of this. No, we don't say that. We don't say that our interval is that good. We're 95% confident that it lies within that interval. And in repeated sampling, we're 95% confident that we can capture it. But we also know 5% of the intervals are wrong. So we had no qualification saying that there's a 5% chance that this is wrong. But consequently, this is also wrong. In repeated sampling, the true proportion of county residents in favoring of offering incentives to high-tech industries would be captured by our method 95% of the time is fine. But we don't know about this interval. There's a 5% chance that interval is wrong, in which case it doesn't lie within there. and repeated sampling 95% of the time, the true proportion of county residents in favor of offering incentives to high tech will be equal to 0.54. And obviously, we don't know if the sample proportion is not. We just say it's 95% sure that it lies in here. We have no way of knowing that that's the case. So in this case, letter A is our best choice. All right, continuing on. Running a confidence interval is very, very similar to what we've done before for means. Our big difference, well, first off, simple random sample. Once again, I would have preferred, and I don't know why I'm going to have to fix this, but this would be 1, 2, 3. But if you do them out of order, it doesn't matter. But I prefer normality to be the third one. Our formula is the p hat. This is our best estimate. This is our margin of error, and that is compared to x bar plus or minus t star s divided by square root of n. Please remember we're using a z star as opposed to a t star, so we'll have to calculate that, and we'll show you how to do that, and our general statements are the same. So moving on to page 181, the local news has taken a simple random sample of union members and found that 87 out of 125 members surveyed said that they will strike. So p hat equals x over n. So in this case, 87 over 125, which equals 0.696. X being the number of successes, n being the number of trials. Calculate a 95% confidence interval and provide a conclusion. So they're claiming that it was 75%. This is from before, and we believe it may be less than 75%. P naught is the true population proportion of union members who will strike if their demands are not met. Please note we have exactly the same conditions as we did when we did the hypothesis test. We have a random sample that was given, simple random sample. We have 125 people surveyed. We believe that there's 1,250 or more in the union. 87 successes, 87 said they would strike. The 38, which came from the 125 minus 87 equals 38. And that is obviously greater than or equal to 10. And we just said that this is 0.696. So we write down our equation. Our equation is p hat plus or minus z star p hat q hat over n. So I'm going to start plugging in, and I have 0.696 plus or minus. I'm going to leave a space for z star. So this is going to be 0.696. And I can either subtract this out and write 0.304, or I can do 1 minus 0.696 for Q, because Q hat equals 1 minus P hat. And this is all over N, and N in this case was 125. So we need to go calculate Z star, and we've actually, this is very similar to doing a T star, except instead of a T, we're going to use a Z, so second vars, inverse norm, the area, parenthesis, 1 minus 0.95, close parenthesis, divided by 2. If you're working with a Z, the mean is always 0, the standard deviation is 1. And we end up getting 1.9599. And we're always just going to make it positive, 1.9599. So that's what I have here. I just rounded up to make it 1.96. I subtracted this and got 0.304. Now to actually get my interval, I'm going to go stats, test, and I'm scroll down to one proportion Z test. And it's right here, one proportion Z test, letter A. My X was 87. My N is a sample size of 125. And my confidence level, they said do a 0.95. Now calculate and I get an interval of 0.6153 to 0.7766. So what can we say? Well, we can say we are 95% confident that the true proportion of union members who will strike lies within this interval. All right. Now I can also note that 75% lies within that interval. And because 75% lies within the interval, we do not have sufficient evidence to dismiss the claim that the 75% union members will strike. In other words, 75% is plausible. The union's claim may be true. It lies within there. Now, the fact of the matter is it could be as low as 61.5%, or it could be as high as 77.6%. So somewhere in there is where we're 95% confident that the true population proportion lies. And in repeated sampling, we expect that this method will capture the true proportion of union members who will strike 95% of the time.